Python, a versatile and powerful programming language, has become a cornerstone in the world of computer science and engineering. Known for its clear syntax and readability, Python allows developers to express concepts in fewer lines of code compared to languages like C++ or Java. This readability makes it an excellent choice for both beginners and experienced programmers. But Python's popularity isn't solely due to its ease of use. It boasts a vast and active community that contributes to a rich ecosystem of libraries and frameworks. These pre-built modules provide ready-made solutions for a wide range of tasks, from web development and data analysis to machine learning and artificial intelligence. For computer engineering students, Python's applications are particularly relevant. It's extensively used in areas like embedded systems, robotics, and hardware control. The language's ability to interface with hardware and process large data sets makes it an indispensable tool for modern computer engineers. As you delve deeper into the world of Python, you'll discover that this versatile language opens doors to countless possibilities in your academic and professional journey. Its intuitive nature and broad applicability make it an exciting and rewarding language to learn. Before you can start writing Python code, you'll need to set up your programming environment. This involves installing Python on your computer and choosing an integrated development environment, or IDE, to write and run your code. Don't worry. The process is simpler than it sounds. First, head over to the official Python website and download the latest stable version compatible with your operating system, Windows, macOS, or Linux. The website provides clear installation instructions to guide you through the process. Once Python is installed, you'll need an IDE. Think of an IDE as your coding playground. It provides a user-friendly interface with features like syntax highlighting, auto-completion, and debugging tools that make coding more efficient. Popular choices for Python IDEs include Thonny, Idle, which comes bundled with Python, Visual Studio Code, and PyCharm. After installing your chosen IDE, you'll need to configure it to use your Python installation. This usually involves pointing the IDE to the directory where Python is installed. With your environment set up, you're ready to write your first lines of Python code. Every programming language has its own set of rules and building blocks, and Python is no exception. Let's explore the fundamental concepts that form the basis of Python programming. At the heart of programming are variables, which act as containers for storing data. In Python, you don't need to explicitly declare a variable's type. The interpreter infers it based on the value assigned. For instance, creates an integer variable while creates a string variable. Python supports various data types, including integers, whole numbers like 10, negative 5, and 0, floats, numbers with decimal points such as 3.14 and negative 2.5, strings, sequences of characters like hello and Python, booleans, true or false values. Operators allow you to perform operations on these data types. Arithmetic operators include addition, subtraction, multiplication, division, floor division, modulo, and exponentiation. By combining variables, data types, and operators, you can create expressions that Python evaluates. For example, calculates the area of a circle using the formula pi r squared, where is a variable storing the circle's radius. Understanding these fundamental concepts provides a solid foundation for tackling more complex programming challenges in Python. In the real world, decisions and repetitions are commonplace. Similarly, in programming, you often need to execute code blocks based on certain conditions, or repeat a set of instructions multiple times. This is where control structures like conditional statements and loops come into play. Conditional statements allow your program to make decisions based on whether a condition is true or false. The statement is the most basic form of conditional execution. For instance, you might use a statement to check if a student's grade is above a certain threshold to determine if they passed the exam. If grade is greater than or equal to 70, print congratulations, you passed. You can extend the statement with a block to specify code to execute if the condition is false. Additionally, the short for else if clause allows you to check multiple conditions sequentially. Loops, on the other hand, enable you to execute a block of code repeatedly as long as a condition holds true. Python offers two main types of loops, and Use a loop when you know the number of iterations in advance. For example, you could use a loop to iterate over a list of numbers and calculate their sum. A loop is more suitable when the number of iterations depends on a condition. For instance, you might use a loop to prompt the user for input until they enter a valid value. By mastering conditional statements and loops, you gain the power to control the flow of your Python programs and make them more dynamic and responsive.